All right, day one functions, part two. We're going to pick up where we left off. We're going to do one more decomposition real quick. We'll just do one of them. I think we'll have the idea down by then. P of y, we're going to break it into m and n. M following n goes first. The output of n goes into m. So that means we're going to decide on what the m function is, what the n function is. I like that circle method. I'm going to circle this right here. E to the 2y minus 7 becomes your first function, which in this case is n e to the 2y minus 7. M of y becomes the remaining, whatever's left over, 3. That thing, that n, y plus 2. Let's check it with composition. M of n of y, m following n, output of n, 3 e to the 2y minus 7 plus 2. Looks like what we started. I don't think we need to do a second one. I think we got it. All right, moving on. Inverse functions. What did we say inverse was? Switching the input and output, switching the independent versus dependent variable, the x versus the y. So in this case, we have a function that describes the number of grams of radioactive substance after a certain amount of years. The grams is g, or r of t, and the t is time in years. So we have r of t, or g, I'm going to use, equals 300 times 0.95 to the t over 4 power. And we need to solve that for t, which would be r inverse. So we got to get everything all moved over to the g side, get t alone. As soon as I see an exponent that I'm going to solve for, I know I'm going to take some type of a logarithm. All right, let's isolate the 300 over first. That gives us g over 300 equals 0.95 to the t over 4 power. Now we want to get that t down where we can solve for it. Here's where we take the logarithm. So we got log of g over 300 equals log of 0.95 t over 4. You know where we're going with this. We're going to shoot that out in front. Log of g over 300 equals t over 4 log of 0.95. Now we just have some numbers we got to get rid of to get t alone. How do you get rid of it? Divide by 4, we multiply by 4. And how do we get rid of it? Times log of 0.95, we divide. Equals t, otherwise known as r inverse. Again, that switch the x and y and solve for y concept. So this says we're going to start with g and end with t. And it says explain. Well, that pretty much explains it. The given function, you would start with the time and you would end with the number of grams that are remaining after the given years. The second function, we're going to start with grams. How many years would it take? To reach that amount. The independent, the dependent switch, the x and the y switch. All right. Next one, average rate of change, something that we have done, I think, every year of mathematics. You started out with slope in Algebra 1, you did it in Algebra 2, we do it again. Average rate of change. As soon as I see that, I think of slope, which means change in y over change in x. Question, what do we have when we're given an interval? Answer is we have two x's. What we don't have are the y's, but that's real easy. We're just going to evaluate the function at 2, and again, our evaluation practice, and at 7. 2 squared is 4 times 2 is 8. 8 minus 10 is negative 2 plus 3 is 1. F of 7, 2 times 7 squared minus 5 times 7 plus 3. 49 times 2 is 98. 98 minus 35 is 63 plus 3 is 66. Now I can go back to our slope formula, change in the y's. 66 minus 1 over change in the x's. 7 minus 2, notice the same order. 65 over 5, average rate of change, slope 13. All right, very good. Moving on. Now we got some applications. Functions that have costs, fixed cost and variable cost. Let's start with fixed cost first. What are those? An example of fixed cost. Never change. What doesn't change if you own a business? Your mortgage. Maybe your advertising budget. Variable costs do change. What changes? Well, if we make more, we need more materials. If we make more, we need more labor, etc. So we're going to create functions that have both fixed cost and variable cost. Fixed costs are going to be more constant. Variable costs are going to be more related to the production, so therefore we'll have a variable in them. So we got a total cost function here. An upstart sneaker company wants to begin production of a new shoe. They anticipate costs of $3 million for startup, research development, facilities. Obviously that's going to be our fixed. And $4,200 per 100 pair of shoes. That's our variable cost. So let's create a total cost function first. T of S equals 3 million fixed, no matter what, plus 4,200, let's call it P for pair, and P equals 100 pair. Sorry if I did P here, I should have done P here. So that's T of P, okay, total cost, fixed cost plus variable cost. Now it says we have to create an average cost function. Well, what's average? Total price divided by number of pair. So average cost equals total cost divided by number of shoes. In other words, 3 million plus 4,200 P all over P. And P is 100 pair. All right, determine that if producing the shoes drops below 5,000 per 100, that's when the company can make a profit. How many 100 pairs of shoes do we need to produce to reach this 500 per amount? Well, that says the 5,000 per 100 is going to be your average. So that's what goes here. And we're going to set it equal to this. And then we're just going to solve for P. To get rid of that P on the bottom, I'd cross multiply. 5,000 P equals 3 million plus 4,200 P. Subtract the P over, leaves us with 800 P equals 3 million. Divide 3 million by 800. P equals 3750. Now remember, that's 100. So I wouldn't write it that way. I would make it into the number. How many pair do we need? Add 2 zeros. 375,000 pairs of shoes would allow us to reach that 500 or 5,000 per 100 average price, and that would allow us to make a profit. All right. Identify and explain in context any horizontal asymptotes. Well, if we think about our unit we just did, I see horizontal asymptote as a limit as x approaches infinity, which I look for the degree of the top and bottom. Degree of top is p to the first. Degree of the bottom is p to the first. So the limit as x goes to infinity of this average price is, when they're equal, it's just the coefficients, 4,200. What does that mean? That means that as production increases, you don't have to say to infinity, but it's getting larger and larger and larger. Average cost will tend to 4,200 per 100 pair. That 3 million fixed cost becomes less and less and less important. All right, one more example then. Looks like that'll be great for the day. We have Sierra's in the process of rehabbing her knee from a torn ACL injury. Her physical therapist asked her to start running 1,200 meters per day, then increase the distance by 250 meters per day. This is very much like what we just did. That's fixed. That's variable per day. But remember, arithmetic sequences are the same as linear functions. So I'm actually going to pull back some sequences and series stuff and go, hey, how did we find terms? It was A1 plus D times n minus 1. So in this case, we have how much she's going to run. How much did she run the first day? 1,200 plus how much is she going to add the difference? 250 times n minus 1. And we could leave it like that, or if you wanted to, we could distribute and clean up 250 times, what do we got? N, and then minus the 250 from the 12 plus 950. Either one. I think we often left it like that, but sometimes with plugging in, it's a little bit easier to go that way. Okay? At the end of 6 weeks, what is that? 6 weeks times 7 is 42 days. So I'd be finding the 42nd term, which is 1,200 plus 250 times 41, or 250 times 42 plus 950. Plug that in and multiply. I got 11,450 meters. It's quite a bit of running. On what day will she do at least 10,000 meters? Plug that in over here and solve for n. Subtract the 1,200, 8,800, 250, n minus 1. I could have, again, used that other formula, but I just chose to use this one. 8,800 divided by 250 is 35.2. N minus 1, add 1, 36.2, which means the 37th day will be the first day she runs at least 10,000 meters. And lastly, we got about a minute left before the video runs out. Write an expression that represents the total number of meters she'll run. So now we're looking for the sum of an arithmetic, which we remember from first plus last times number of pairs. First term plus last term, second term plus second last term, and so on and so on and so on. So if we wanted to know 2 months, I'm going to call it 60 days. So that means we have S sub 60 equals A1, 1,200 plus, what's AN? 250 times 60 plus 950. 250 times 60 plus 950 times 60 over 2. And again, I'll do it real quick. My final answer, 47.975.